Hi, in this video I show you how to solve the problem of Tower of Hanoi using the recursion. And you can see that recursion can help us to give a simple solution for a very complex problem. And you can see the beauty of recursion. So let's go. So Tower of Hanoi, this is the problem. There are three towers, and then this of different size. So for example, we have some of the discs here. One of the discs have different size. The disc start as ascending order. You see that this is ascending order, right? Of the size of one tower. So for example, one tower, which is tower 1. And after that, the objective of this problem is to move all the stack to another tower. So for example, we need to move all the stacks of the disc from tower 1 to tower 3 with some condition. So the rule is that only one disc can be moved at one time. The other tower can be used temporarily to hold the disc, and larger discs cannot be placed on top of smaller discs. So what does it mean? It means that I can move the disc to another tower temporarily. However, I cannot put a larger disc on top of the smaller one. So this is not allowed. Instead, if this is the situation, then I need to move either the disc in tower 1, which is here, to tower 3, or the disc from tower 2 to tower 3 only, in order to follow this rule. So let's start with coding. We need to write a static method, right? This method doesn't need to return anything. This method is to move this, right? And then we'll have number of this. What we'll have here, we'll have from tower, right? So the name of the tower that the disc star, and then after that to tower, so the name or the ID of the tower that the disc need to reach, and after that temp tower, right? The tower used to temporarily hold the disc. So we have 3 tower here. So this is the one. So we're done, right? Do we need to return anything? So we don't, right? So now, how can we solve the problems? Let's go. Let's see that. Let's start from the very simple situation that only have 2 discs. Of course, if only have 1 disc, then we just move one disc from tower 1 to tower 3. It's very simple. How about 2? In order to move 2 discs from tower 1 to tower 3, the first step, we can move the first one to tower 2, and after that, we move the second disc to tower 3. And finally, we move the disc to tower 3. So we're done, right? Simple, isn't it? If only 2. How about if there's many? Maybe 3, maybe 4, maybe 5, maybe 6. So now is the beauty of recursion. How we can solve the problem with more than 2? I don't know. And I don't even care about how is the solution. But I know that. So this is the key thing, right? Again, right? Computer can always solve the problem automatically already for me. How? I don't care, right? I don't care, but I know that computer can always solve sub problem automatically. So let's see that. Let's look at number 3 here. I know that computer can help me to move a smaller number of disks. So for example, in CAC 3, maybe computer can help me to move 2 of them to any tower. Then, how can I solve the problem? So if computer help me to move 2 of them to any tower, the problem is becoming this situation again. This is the key for this solution, right? You look at this. This one is 3, but actually we can divide it by only, 2 paths. The first path is this 2. This happened. First of all, I move the first 2 to tower 3. After that, I move the last one to tower 3. And after that, I move the first 2 to tower 3. I'm done. So let's, again, right? Let's work with more than 3 discs. For example, here we have 4 discs. Again, I don't need to look at for this because I know that computer can help me to solve the problem automatically already. It means that I can move 3 disk to anywhere I want. So in this situation, because computer helped me already, I just move the 3 disk from tower 1 to tower 2. So this is my first step. My second step is that again I move the last disk to tower 3, and finally I move the 3 disk to tower 3, and I solve the problem. And this happened again and again, not only for 3 disks for this, but also more than that, 5, 6, 7, 8, or 10, or even much more than that. So if you give me n disk, I move n minus 1 disk to tower 2, and after that I move the last disk to tower 3, and finally I move this n minus 1 disk to tower 3, and I solve this problem. Let's see how can we implement this situation in our code. This one is example is C#, but you can implement it in any language that you want. So let's go. Only 3 steps, right? So the first step is what? Move n minus 1 disk to tower 2. So to the 2 tower, right? So in this situation, tower 2 here is the 10 tower. Step 2, move the last disk. So the last disk is only 1 disk to tower 3, right? So tower 3 is to the destination tower. 2 tower is the destination tower. And step 3, I will move n minus 1 to the destination tower. It's the last 3, move the n minus 1 to 2 tower. And then I'm done. Right. So let's see how can we implement this one. I move n minus 1 to 10 tower. So I just call the recursion move. How many disks? Right. Number of disks minus 1 to temporary tower. So from is the same thing. Now 2 tower become a temporary tower. This is the key thing, right? From the same thing from, and then now the destination is the temporary tower. Just look at here. All right, so this is the one. I move this one to the temporary tower. From tower to temporary tower. And now I using this other tower. So this tower 3, the destination tower, is the temporary tower. First step done. Second step, I move 1 to tower. So I just move this. Again, 1 only. From tower to tower, right? So the destination tower is the same. Right? So this is the situation. From here to here. So the 2 tower here is the same. And then again, I use the others as the temporary tower. Now, the last step is I move this. Again, I move number of this minus 1 from where? So now it's from here. This is the temporary tower. From the temporary tower to where? To the destination tower. Using from tower is the temporary. So this one is the from tower. And surprisingly, I've done. Isn't it? Does it work? Okay, let's see. Right. However, before make it work or not, we need to look at this one. Right. We say that, hey, the recursive method perform the task by calling itself to perform subtasks already. So we've done this one. However, we need to say that at some point the method encountering subtasks that can perform itself does not need to call the subtask anymore. And this is the one. We need to find the base case. So in this situation, what is the base case? We look at this destination again, right? What we try to call this recursive method is n minus 1. So this is n minus 1. And here from 4 is n minus 1. This situation is minus 1. Later is minus 1 again. Later is minus 1 again. And later is minus 1 again. Until when? Until only 1 is left. So we can look at it and we can see, oh, if only 1 is left, then we'll have the situation of something like this. Right. So only 1 is left. I just print out from where to where. So the only one is left is the base case. Right? So this is my base case. If number of this only one, then what I do? Just write line, right? So this is the one, this is the base case, right? So we want to move this from tower to, and we've done, right? And because of that, if the base case, then we do it and then we return. Yes, we don't want to call any recursion, anything. So we've done the coding. Let's test if our coding work or not. So in here, I test moving 1, and then after that moving 2, from tower 1 to tower 3, temporary tower 2, moving 2 again from tower 1 to tower 3, and temporary is 2, and etc. So we'll move 1, and after that we test 2, and after that we test 3, and etc. So let's go. This is the output. It worked. Amazing, isn't it? So if I want to move this, so of course we only need to move from 1 to 3 so right away. If I want to move to this, so the first step I want is to move 1 to 2, correct? And after that from 1 to 3, correct? And after that from 2 to 3. So we're done. So to this, okay. How about 3 disk? We move from 1 to 3, all right? After that from 1 to 2. After that from 3 to 2. After that from 1 to 3. After that from 2 to 1. After that from 2 to 3. Finally from 1 to 3. Right? So you see, it works. And if you believe me, it will work for 4, for 5, for 6, for 7, and for all the things. So in here you can see the power and the beauty of recursion, in which because what? Because computer can always solve the problems for us. We don't even care how they solve the problem. We just make sure that they have solved the problem for us. We just try to solve the whole problem and make sure that we have the base case ready. I hope you enjoyed the video and thank you very much.